Okay, welcome back to your next video. Today we're looking at simultaneous equations, solving them using the elimination method. The other day we did the substitution method. Let's look at my favorite method now. Alright, so this is exercise 2J. Yes, there are multiple methods to solving simultaneous equations. Substitution is often good, but sometimes it gives us tricky fractions in our equations, which we tend to make mistakes with. So elimination is one way of trying to avoid that as much as possible, and we're going to look at exactly how that works now. So often you set it up where you've got ax plus by equals d and the x and y on the same side. It could be done like that. It could be done in the y equals mx plus c form, but we'll just have a look and see how it works. What you need to do is you need to get the coefficients of at least one variable, either the x or the y or whatever other variables you're using. Get them to be the same magnitude. By magnitude, I mean the same number in front. It could be one could be positive and one could be negative. That's okay as long as they're the same size. So in this first little example here, you can see that the number in front of y, well, there isn't one there, but it's a 1, isn't it? Here I've got negative 1y, and in the second equation I've got positive 1y. If I add those two equations together, just as they have there, you're going to see 3x plus 5x, well, that's going to give me 8x. Negative y plus y is going to cancel out, isn't it? If I take away y and add y, that's effectively no result. So 3x plus 5x gives me 8x, and then adding the right-hand side, 4 plus 4 gave me 8. We could then solve that to get x equals 1, substitute it back in, and find the y value. If the coefficients are the same, and in this second example here, we've got 2x and 2x, so they're both positive, then to get rid of them, to eliminate them, I'd need to subtract the second equation from the first one. So when I go 2x minus 2x, that will give me 0x. That's going to work out nicely for me there. One thing I would encourage you to do, which they haven't done in their little examples there, but I'm certainly going to try and encourage you to do it, is when you're doing this, just put brackets around that whole equation, just to make sure, so we can see how did they end up with 8y here. They had negative 3y minus negative 5. That should be plus 5. Negative 3y plus 5y. That should be 2y. You can see there they have not done that. So you just need to be careful. It's okay. I'm going to go through an example that will work for you, and we'll see how we go. But that's where people get caught out. Let's not be those sorts of people. No catching us out. All right, let's have a look here. Solve the following pair by elimination. So I'm going to do question A. And I'm still going to label my equations, equation 1 and equation 2. Just like we did when we used the elimination, the substitution method. Zoom in a little bit here. All right, now are the coefficients of either x or y the same magnitude? Yep, I can see the number in front of x is 1 in the first equation. It's negative 1 in the second equation. So I'm right to go. Now, am I going to add or subtract? Well, when they've got different sides, if I've got a positive and a negative, if I add them together, that's going to, of course, eliminate the x. So I'm going to go equation 1 plus equation 2. What does that give me? Well, x plus negative x would disappear. Negative 2y plus 5y, that's going to be 3y. And 1 plus 2 equals 3. We can solve that straight away. Dividing each side by 3, I've got y equals 1. Then I'm going to, just like we did before, let y equal 1. Now I could choose either equation 1 or equation 2 here to find x. I'm going to choose equation 1 because the coefficient's positive there, isn't it? It's a positive x. It's going to get me to my answer a little bit quicker. So one of the things you can do to help yourself out when you're doing your maths exams or just your working class even, think about it before you act. Think, do I want to substitute it into the first or the second equation? Which one's going to be easier? Here, I'm going to have a positive x. That's going to save me a step. So I'm going to substitute it in 1. So now I'm going to have x minus 2, and instead of y, I'm going to substitute in 1, just like I said I was going to. So x minus 2 times 1 is equal to 1. X take 2 equals 1. Add 2 to each side. X equals 3. Therefore, the solution is... And I'm going to put it in coordinate form this time. 3, 1. And if I check that in the equation, 3 minus 2 times 1, 3 minus 2 is 1. What about negative 3 plus 5 times 1? So negative 3 plus 5? Yep, that equals 2. We know we've got the right answers. I'll do another one here for you. 3x minus 2y equals 5. 5x minus 2y equals 11. I've got my two equations there. You can label them on the left if you'd rather. It doesn't really matter to me or anyone else. As long as we're clear what we're doing, that's fine. Here, the sign in front of the y's was the same. It was a negative in each case. So I'm going to need to do some subtraction here. So 3x minus 5x. Now, if I want to be really clever, see how that's going to give me a negative? I might say, let's do equation 2 minus equation 1. Rather than ending up with a negative value for x, I want to end up with a positive x. So I'm just going to do my subtraction. I can still leave it set out this way and just go the bottom one minus the top one. So 5x minus 3x is 2x. Negative 2y, when I take away negative 2, that's adding 2y, they're going to disappear. Negative 2y plus 2y is 0, so I've got 2x on the left, and 11 minus 5 equals 6. Straight away you can see the answer, x equals 3, and then it's a matter of substitution. In this one, I don't have a situation where I've got a positive coefficient for y, so it doesn't matter which equation I substitute it into. I'm going to let x equal 3, and I'll just go for equation 1, because why not? Therefore, I'm going to have 3, and instead of x, I write 3. 3 times x minus 2y equals 5. So that's equivalent to 9 take 2y equals 5. Subtract 9 from each side. I've got negative 2y. 5 minus 9 is negative 4. Dividing by negative 2, I'm going to end up with y equals 2. Therefore, the solution is x was 3 and y is equal to 2. Quickly checking your answers, just make sure you've done it correctly. If I put 3 in for x and 2 in for y, I'm going to have 9 minus 4. Yes, that's equal to 5. And check the second equation as well. 15 minus 4, that's 11. That's good. You're right to go on and start the work, but I'm going to do example 21 just to make sure. This is an example where none of the coefficients are the same first. I'm going to do A. I'm going to leave you to do B on your own, but let's just see how I go about doing A. So I've got equation 1 is 5x plus 2y equals negative 7, and equation 2, x plus 7y equals 25. Well, if none of the coefficients are the same, what I'm going to do first is I'm going to take equation 2, and if I multiply it by 5, you're going to see that the coefficients of x will then be the same. So I'm going to do that as my first step. What does that give me if my pen wants to start working again? No, OneNote wants to close. That's not very helpful. Oh, I'm having fun today. So let's just keep going again with where we're up to. So here I've got the first equation, 5x plus 2y equals negative 7, and my second equation, x plus 7y equals 25. Just going to zoom in a little bit so we can see it a little bit more clearly. As I was saying, the coefficients are not equal in any for either x or y. I want to make the coefficients equal. Multiplying 2 by 3.5 would get me to 7, but multiplying by 3.5 doesn't sound like a good idea. It's going to introduce fractions, and we're trying to avoid that. So what I might do is multiply the second equation by 5. What's that going to give me? Because then it's going to give me the coefficient of x to be the same. So let's see. 5 times x, of course, is 5x. 5 times 7y is 35y. And 5 times 25 is 125. Now if I write equation 1 underneath that one, I've got 5x plus 2y equals negative 7. This is looking better. I'm going to be able to do subtraction here. 5x minus 5x, 0x is going to disappear. 35y, take away 2y, well that's going to be 33y. 125 minus negative 7, so I've got to add that 7 on. It's going to give me 132. Divide each side by 33, and we're going to have y is equal to 4. Have I finished? No, of course I haven't. I need to substitute that back into one of the first two equations. I'm going to go for equation 2 because it's just got the coefficient of 1 for x. It's going to be the fastest one to solve. So let y equal 4 in equation 2. Therefore, x plus 7 times 4 equals 25. X plus 28 is equal to 25. X equals -3. Therefore, the solution is and I'll write it the other way. Why not? X equals -3, Y equals 4. Let's just have a check that works for both of them. 5 times -3, -15, plus 8, that would be -7. That's right. And substituting in -3 and 4 again, I got -3 plus 28, 25. Looks like we're going okay there. Equation for the second set of equations here, B, you've got an option here. I've got a 4 and a 3, a 3 and a 2. If I wanted to make them, I could multiply the second equation by 1 1/3 to get it equal to 4, or by 1 1/2 to get it equal to get the y coefficients equal. It's not going to be so good, is it? What we do in that situation, I'll just start you off and then I'll let you go from there, is you try and make either the x's the same or the y's the same by finding the lowest common multiple. So I could have 3 and 4 both go into 12, so I can multiply the top equation by 3, the bottom one by 4, and then my x's would be the same. But if I've got one positive and one negative, I usually like to do those two coefficients, get them the same size, because then I can add rather than subtract. And we all know adding's easier. So what I'm going to do for that one is, again, if I have equation 1 and equation 2, I'm going to multiply equation 1 by 2. And that's going to give me 8x plus 6y equals 36. And equation 2, I'm going to multiply it by 3. What's that going to give me? It's going to give me 9x minus 6y equals 15. And you can see at this point, if I add those equations, the y's are going to eliminate. All right, I'm going to pause, give you a chance to try that one yourself. It's a slightly longer video today. Good luck and well done for sticking with it. Good luck getting this one right. Pause the video, finish it off, and we'll see if our answers match. Okay, hopefully you've had a go. Once I added them, I got x equals 3, substituted that in, and I got y equals 2. If you substitute that into each of the equations, you'll see you've got them right. Good luck with your working today. Don't forget to have a go at those quick points there. Good little skills to practice. You can check the answers down the bottom and fill in the form at the end of the day with what you've managed to get done. Keep up the good work. We will catch you in the next video or in a Zoom lesson if we have one coming up soon. Whichever way. See you soon, guys. Bye.